complexification and learning. If it is true that meaning arises from the mutual information correlating entities and environments, and that these entity field dynamics complexify through the emergent levels of matter, life, mind, and culture, then entities at all levels can be understood as engaging in an increasingly complex learning process whereby more sophisticated forms of meaning emerge. If for anything to exist means it has navigated its environment successfully enough to have not succumbed to entropy, then there is meaningful information linking that entity to its conditions, and so also what Azarian calls knowledge, even at the most basic level. The learning process of entities in the universe, then, can be understood as extending from the most complex adaptive organisms like human beings on the culture plane, down to animals in their environments on the mind plane, down still further to biological entities like single-celled organisms and plants on the life plane, and, I would argue, even shades down into the plane of matter, where inanimate objects can complexify through pre-Darwinian forms of evolution, for example, autocatalysis, dissipative adaptation, etc., and whose very existence as objects may even arise from quantum decoherence mechanisms based on similar selection pressures, though calling this learning obviously stretches the term to its breaking. To delineate these distinct levels of learning relative to complexity, and thus their relative kinds of meaning, we can speak of 1. Structural learning connected to matter, 2. Genetic learning connected to life, 3. Cognitive learning connected to minds, and 4. Symbolic learning connected to culture. Through these, increasingly complex forms of learning, purpose, and value emerge to grow more rich, comprehensive, and integrated. The majority of this book series will focus on the sort of learning that takes place on the culture plane. But before we arrive there, let's take a journey through the preceding levels that lead up to and give rise to such complex human meaning, a path connecting us to the universal learning process. Structural learning. Matter. We start at the lowest level, begun nearly 14 billion years ago, where learning seems at best a semantically loose description for the sorts of processes underway. That is what we should expect, though, if we mean to trace the continuum from the crudest, most provisional forms of adaptive information processing up to the most complex. At this basal level, we are dealing with the very rudiments of the objective world and how they come into being. Here we ask, could this process also be subject to the sort of viability filtering mechanisms that characterize genuine learning at higher levels of complexity? John Campbell thinks so. In his books Universal Darwinism, The Path of Knowledge, and The Knowing Universe, Campbell draws on the 2009 work of theoretical physicist Wojciech Zurek of the Los Alamos National Laboratory to show how quantum decoherence, the process by which quantum states become determined as classical reality, operates in terms of inferential information processing. Since the early 20th century, quantum mechanics has puzzled physicists by its fundamentally probabilistic nature, which is so unlike the deterministic certainty of classical physics. Do all possible states of quantum phenomena exist then, somewhere, somehow, perhaps in a multiverse of some kind? The seeming gulf between a quantum world of probability and a classical objective world of definite objects has left theoretically unresolved the transition from one realm to the other. Zurek, Campbell, and other proponents of quantum Darwinism resolve this question by seeing the transition to the classical objective world as one of information transfer subject to environmental selection. Quote, only the effects of quantum systems that can pass through the filter of decoherence compose our reality. Campbell writes, quantum systems participate in reality only through those interactions. When analyzed in detail, these interactions or quantum decoherences consist of a transfer of information between the quantum system and the web of objective reality. Not all information concerning the quantum system is transferable. In fact, the vast majority is not transferable. The relatively tiny amount of information that can be transferred is selected from the huge range of quantum possibilities and the numerous copies of this information which are deposited in the environment by a Darwinian process. In this way, when interactions occur, only the environmentally viable information is selected from the vast variability of possible states. The resulting conditions then form the informational basis for determining future selection, and so on. Because of this, the very fabric of reality arises through a sort of quantum computation, which is continually updating the realizable possibilities of future states of the universe. So framed, the objective universe is itself the acquired knowledge, i.e., the adaptive information of a quantum learning process. Such quantum computational models are compelling, but admittedly speculative. Once entities have entered the classical plane of deterministic matter, however, we are on surer ground. It is clear to see how interactions among physical particles unfold within the object-field relationship of the PTB. For a particle's activities become impinged upon by other particles and forces in its environment, which affect its viability as a stable, persisting entity. In the proto-Darwinian struggle for survival, not of the fittest but simply of the stable, particles that formed into enduring atoms outcompeted particles that did not, and so persisted. Among the vast variations, some stability gets selected for by the environment. And though material objects are not in any way animate agents in this process, let alone conscious or volitional ones, the end result is the endurance of structure against entropy through being well fitted to an environmental niche, the basis of the entity-field relationship, and so also of meaningful information. But again, is this really learning? Admittedly, given the very minimal degree of complexity at this level, using a word like learning for such interactions which are so alien to our sense of the term may seem specious. Nevertheless, it is the indisputable continuity with later forms of learning that I believe renders such an interpretation eminently valid. Indeed, one need not rise all the way to the level of life to see this made plain. The dissipative structures described by Nobel-winning chemist Ilya Prigozhin represent a much clearer instance of purely material objects navigating the energy dynamics of their environment to push back against entropy and maintain structural persistence, the essence of learning semantic information as defined above in this book. Such structures include entities like whirlpools, hurricanes, and tornadoes, which more effectively dissipate free energy through the spontaneous emergence of greater order. Indeed, we can recognize that they arise, functionally speaking, to dissipate that energy. If meaningful information is what allows an entity to maintain its informational structure in the face of entropy, then we are forced to conclude that such entities even have meaning. From here, one can track the process into genuine dissipative adaptation, such as Jeremy England and others are exploring, whereby the specific environmental conditions of the energy itself actually select for what structures emerge. Teleological or goal-directed behavior is thus evident even in prebiotic entities. That is, all of this learning unfolds entirely on the plane of matter. And while the details of abiogenesis out of dissipative adaptation remain to be filled in, there are promising signs that the evident continuity between material dissipative structures and biological organisms, which are clearly a subset of the former, will offer new revelations about the origins of life. At the very least, it shows us that an entity need not be a full-blown biological organism to exist in an entity-field relationship whose correlation defines meaningful knowledge to the entity. Rather, a very crude, simplistic form of meaning exists even for a whirlpool, as Kulczynski and Wolpert's framework posits. While this may seem at first to diminish the very idea of meaning, it actually does the opposite, I believe. For by showing that meaning connects down into the very rudiments of reality, we can see the error, common these days, of presuming it to be merely subjective, or as a thing that only humans make up as some arbitrary social construction. To the contrary, meaning, along with a related word, teleology, are both quite real, something cyberneticists and complexity scientists have long appreciated as they endeavored to explain goal-directed material phenomena like dissipative structures. As Azarian concludes, with dissipative structures, a natural pressure to minimize free energy and produce entropy spontaneously creates an ordered structure with an objective function. With the emergence of dissipative structures, we see the emergence of purpose in nature. Genetic learning, life,